All right, I guess we can start. Are there any questions? Can anyone hear my voice? And you see the module 6, OneNote? Okay, so I got a few questions from students. So I will go over those questions. The due date for module 6 is Friday by midnight, okay? So we are go over maybe the second question. The following information is available for 2 samples drawn from independent, normally distributed populations. Population A, the sample size 25, variance S represents standard deviation, S square is variance 160.3, and population B, sample size 25, variance equal to 186.6. The question asks you, what is the value of test statistic for F if you are testing the null hypothesis H0, sigma 1 square equal to sigma 2 square? Okay, that is the question. Before we answer that question, I want to clarify some notations. S represents sample, okay? So sample variance, you use S square, but for population variance, we use sigma square. You see, sigma 1 square represent population 1 variance, and sigma 2 square, population 2 variance, okay? So based on the formula, test statistic F equal to sample 1 variance divided by sample 2 variance. So S1 square divided by S2 square. And now, which one is S1 square? Which one is S2 square? We have a rule, we have a convention. The convention is always put a bigger variance as a numerator. So in this case, population B is 1, and population A is 2. The reason is population B has a bigger variance, 186 greater than 166, okay? So when you use formula, always put a bigger number on the top, okay? And then you use 186.6 divided by 166.3. Okay, and you would get the answer 1.12. Okay, any questions for this one? This is the first time we are encounter F test, F distribution. Before this module, we have Z distribution and we have T distribution, okay? The F distribution is not bell-shaped. It is skewed to the right, something like this. Okay, this is the F distribution. The value for F is always greater than 0. You never have a negative F. The reason is the formula for F is square divided by square. Something square is always a positive number, okay? So that is the F test statistic. Once you get this F test statistic, use critical value method compare this F test statistic with the critical value of F. And this is the topic we are going to turn to. How do I find the critical value of F? This is the question. Oh, here, I go question 6. Question 6. Determine the upper tail critical value of F in each of the following two-tailed tests. Okay. So when you have a two-tailed test, this question only asks you upper tail critical value. Okay, so you actually have, this is upper critical value. You have another critical value here. And this critical value is lower tail critical value. Okay, the question only asks you for this one, upper tail critical value. And this is two-tailed test. Okay, and this one, we have to depend on our calculator, or you can use the F distribution table. Okay, so first let's do the calculator method. Okay, so I have my calculator ready. Okay, so this is a calculator. Okay, hope you can see it. So the starting point, F5 distribution, and then F4 F distribution. After that, F3 inverse F. Okay, so I write down it is F5 okay, distribution, then F4 F distribution. After that, F3 inverse F. Okay, so and then you see data. Not sure you can see it. Maybe the light. Data variable, okay, make a data variable. Area, when you have two-tailed test, half alpha is area. Alpha divided by 2, that is the area. So the first question alpha 0.01 divided by 2, you get 0.005, that is area, and you enter the calculator. So 0.005, okay, that is area, and then you have NDF, means degree of freedom for numerator. Remember what is F? F equal to S1 square over S2 square. What is S1 square? Sample 1 variance. S2 square, sample 2 variance. Okay, so NDF means what's the degree of freedom for sample 1? Okay, so let's go back to question 4. NDF, sample 1 is N1, 16. 16 minus 1, 15. So 15 is the NDF. Okay. And next, you are asked DDF, means degree of freedom for denominator, means sample 2. Sample 2 sample size is 10 minus 1, so it's 9. Okay. After that, you just press EXEK. If somebody share your answer, what did you get? After F5, F4, F3, and then this is the number I type in, area 0.005, NDF 15, DDF 9, and then press EXE, okay? And I get 6.0325. So it is here. This is the number I get. This is 2 decimal place. Okay, oops, where we are. Okay. So any questions about question 4? How do you find a critical value for F? Okay, this is the starting point, critical value for F. Okay. So we did question A. Now let's do question C. Similar, okay, similar step. We quickly go question C here. So you go back, you start with F5, F4, F3, alpha 0.05, you have to divide it by 2 to get area, because this is a two-tailed test, okay? So area 0.025, 0.025 is the area. NDF is 15, DDF is 9, and you press EXE. And I get 3.7695, so 3.77. Okay. Any questions? All right, so that is the critical value for F. Now let's go back to question 3. Question 3. This is I get from another student. In a study of cognitive skills required for successful arguments, 50 psychology graduate students were equally divided into 2 groups. Group 1 was presented with arguments that always attempt to strengthen the favored position. Group 2 was presented with arguments that always attempt to weaken the non-favored position. If you compare the mean ratings for the 2 groups with a small sample t-test, assuming equal variances, determine the validity of this assumption at 0.05 level of significance. Okay, and this one, you need the summary statistic. Okay, you need that number. It is given. So summary statistic give you S1 square, S2 square. Okay, but first let's determine the null and alternative hypothesis. Okay, so what you are testing? You are testing. Oh yeah, summary statistic is here. You have here. Okay, summary statistic. This is summary statistics, okay? And hypothesis H0 equal. Okay. So sigma 1 square equal to sigma 2 square means population 1 variance equal to population 2 variance. Okay. H1 is the same as HA. Okay. Sigma 1 square not equal to sigma 2 square, not equal. Okay. So that is your H0, H1. And the next, ask you what is the test statistic? Okay, I'm going to use 2 methods. Okay. Method 1, use a formula. So test statistic F equal to S1 square divided by S2 square. Okay, so summary statistic is given. See, standard deviation. So this is S1, this is S2. Remember, as a convention, always put a bigger number on the top, a bigger number on the top. So you put 12.6 squared, 12.6 squared divided by 12 square. Okay, and you are going to get 1.103. So that is a method 1, use formula. Okay. Method 2, we use calculator. This is a, I want to make sure that student is here. He is not here. Okay, he asked the questions. Okay, so the other method is, oops, move it over here, to use a calculator. Okay, so you start with F5 button, distribution, then F4, F distribution, and after that, this is for critical value. This is later on. Okay, so for method, okay, I'll start. We did method 1 formula. We calculated test statistic F. Next, method 2, okay. When you have calculator in front of you, you just press F3 test, okay, and then F4, F test, F3 test, then F4, F test, okay, and then data variable, okay, sigma 1 not equal to sigma 2. Remember, calculator is based on H1 perspective. H1 said sigma 1 not equal to sigma 2. So you select not equal. And then you are asked what is the SX1 represent sample 1 standard deviation. That is 12.6. 12.6 is SX1. And N1 sample size 25. Do not confuse sample size with degree of freedom. Here, you are asked sample size, 25. And then next, you are asked for SX2, sample 2 standard deviation, 12. Then N2, sample 2 size, that is 25. And after that, you press E. So this is the number I entered. Okay, and the last step, you press EXE. Okay. And you get the test statistic 1.1025. At the same time, you also get the p-value. Okay, 0.813 is the p-value I get. Okay, this p-value is 0.813. Oops, mouse is. P-value I get 0.813. 0.813. Okay, and once you have a p-value, you can use the p-value method to make a conclusion. Okay, remember the rule, the convention for p-value is when p-value greater than alpha, do not reject. So this p-value obviously greater than alpha. So where is my alpha? Okay, here, alpha is given 0.05. When alpha is not given, usually people will use 0.05. Okay, so we conclude p-value greater than alpha, do not reject H0. So A, B, C, D, which one do we select? We select the one said H0 not rejected, either A or C. Okay, so A said the assumption appears to be valid. And C said the assumption appears to be incorrect. So which one do we choose? So C, assume equal variance, that is the assumption. Okay, means assumption appeared valid. Okay, so A is the correct answer. Do not reject H0. Two population variants are equal. Okay. Any questions? So this question is a very typical question for an F test. Usually you can use two methods to get the test statistic for F. Method 1, use formula F equal to S1 squared over S2 squared. And method 2, use calculator F3, F4. Okay, by using calculator, you also get the p-value. And then you use the p-value method to draw a conclusion. Okay. Any questions? Okay, I have a question for everyone. Why H1 said not equal? Why not greater, not smaller? Why? Remember, H1 could be greater, H1 could be smaller. Why you choose not equal? Why you don't choose smaller? Why you don't choose greater? Why?
Because H0 is equals, so therefore, if it is equal, the alternative H should be not equal.
Excellent. Because the assumption that H0 is equal. When you have equal, usually the opposite of equal is not equal. But under what condition do you use H1 is greater? If you, under the context, if you see which keyword, you are sure H1 must be greater. Which keywords indicate H1, you must use greater sign.
When HO is less?
When actually HO is smaller, equal.
That's what I meant, sorry.
Okay, yeah, because remember you have to pair H0 with H1 together. And from the context, how do you know you choose greater as H1? Usually there are some keywords, greater than, more than, enhanced. You see nothing of this keyword in this question. Did you see enhanced, greater than, more than? No. That's why you do not select greater as H1. Similarly, you do not select smaller as H1 because you do not have any keyword in this description indicate smaller than, less than, weaker, decrease. You do not have any of those keywords, so you do not use this smaller as H1. Okay, suppose you use smaller as H1, H0 usually is greater equal. Okay, so they have to pair together. This usually pair together, this together, and this together, usually. Okay, I say usually because there are some other combinations. For example, some textbooks said H0, they use equal, and H1, they use greater. That's fine, that's correct. In case you have multiple choice question, it is still correct combination, okay? Another combination could be H0 is equal, and H1 is smaller. Again, this is the correct combination. Okay. Any questions? All right, so this is question 3. And we did question 4 already. And then I believe I have, who asked me that question? Question 8 and question 11. So I will do question 11 first, then do question 8. So I label the question. This again from another student. Sorry for my little doggy. Question 11, where is my question 11? Question 10. Question 11. Okay, here. Okay, this is question 11. Okay. Independent random samples were selected from each of 2 normally distributed populations. Sample 1 size equal to 6 from population 1, sample 2 size 5 from population 2. The data are shown in table. This is the table, okay? Sample 1, sample 2. Complete parts A to C. Okay. So test H0, sigma population 1 variance greater equal to population 2 variance against HA. HA is the same as H1, okay? A stands for alternative. Okay. So H1 or HA, sample 1 variance, smaller sample 2 variance, use alpha 0.01. Okay. And then the question asks you, what is test statistic? What is p-value? Okay. So this question, the raw data is given. Okay, original data is given. How do you find F? How do you find p-value? Okay, so step 1, you need to enter data as list. Okay. Oops. Need to write a note here. Okay. Enter sample 1 as list 1 on your calculator. Enter sample 2 as list 2 again on your calculator. Okay, so if you have calculator, I give you a few moments. You can get a taste what is feels like using calculator. So this is my list 1, sample 1, and this is my list 2, sample 2. I believe I already entered data in my calculator. I will just show you. Actually, I entered in list 3, list 4 because I have useful data as. So in my calculator, I entered sample 1 as list 3 and sample 2 as list 4. Doesn't matter, okay? So enter one sample as one list, the other sample as another list, okay? So I give you maybe just a few moments. You enter the data. So suppose you entered the data. How do you find the test statistic and p-value? So you do this. So okay. Oops. Want to continue here. So you press F3 test button. F3 and then F4. F test. After that, data, make sure it is a list, not variable. Data is list. But when you look at your calculator, you see data variable. How can you change from variable to list? You press F1 button. F1 button will allow you to change from variable to list. Okay. And then you have sigma 1 not equal to sigma 2, or sigma 1 smaller than sigma 2, or sigma 1 greater sigma 2. Which one should you choose and why? So after data list.
Less than 2.
Wow, less than. Fantastic. Why?
Because
you select sigma 1 less than sigma 2. Why?
It's because the calculations are based on H1, the alternative.
Fantastic. Calculator is based on H1 perspective. In H1, what did you see? You see smaller than. So you must select sigma 1 smaller than sigma 2. I said smaller, I type in greater. So sigma 1 smaller than sigma 2. This is important. Calculator based on H1 perspective. Okay. So after you select sigma 1 smaller than sigma 2, and then if sample 1 is your least 1, and you are asked least 1, that is your least 1, and then least 2, that is your least 2, okay? And then frequency 1, just keep the default setting, frequency 1, and you have another frequency 1. So after all of this, you press EXEK. You press EXE, and you will get F test statistic. Anyone want to share your result? F equal to 0.2538, and you also get p-value. P-value 0.0825. That is from calculator. Okay. Any questions to get p-value and test statistics from calculator? So we get this, we completed those. Okay, this is the outcome. So maybe to emphasize, oops. Just want to change the font color so that you know that is okay. So we did p-value. Remember p-value 0.008, and now ABCD multiple choice questions. Okay, make a conclusion. So before we see ABCD, let's see this p-value. Compare p-value with alpha. Where is my alpha? Did anyone see alpha? Yes, alpha is here. See, alpha 0.01. Okay, so compare p-value with alpha, and this p-value obviously smaller than alpha. This p-value smaller than alpha. When you have p-value smaller than alpha, you reject H0. You reject H0. Okay, so that is our conclusion. So A, B, C, D, we select one, reject H0. So either A or B. But A said there is insufficient evidence to conclude that the variance of sample 1 is less than the variance of sample 2. And B said there is sufficient evidence to conclude that variance of sample 1 is less than variance of sample 2. Which one would you select? So our conclusion is reject H0. So how do you interpret reject H0?
There is sufficient.
Right, there is sufficient evidence to conclude the variance of sample 1 is less than the variance of sample 2. Okay. So any questions? Again, this question is very basic and fundamental. It involves lots of basic concept about hypothesis test. You see, this is actually left-tailed test. Did you see this? Left-tailed test. And you can use the p-value method to draw a conclusion. Okay. If I ask you to use the critical value method to make a conclusion, what would you do using critical value method? So that is my question. The question is, how do you use critical value method to draw a conclusion? Anyone? Remember critical value, you compare critical value with test statistic. Where is your test statistic? Remember we get F, oops. We get F. See F 0.2538. This is your test statistic, right? And then you found the critical value for F. So how do you find critical value for F? Remember question 4. Use question 4 method.
F5, F4, F3.
Yes, excellent. So I just want to show you in case some students, how do you find critical? See, based on this method, you can find the critical value, right? And once you found the critical value, so what? You compare critical value with test statistic. Remember, the role, the function of a critical value is to decide rejection region and rejection region. In this case, okay, those shaded area are the rejection region. Okay? And if your test statistic is here, suppose your test statistic is here, when test statistic is in the rejection region, you reject H0. The same principle as we did for the t-test, for the z-test. When test statistic is in the rejection region, you reject H0. And when test statistic is here, for example, test statistic is here, it is not in the rejection region, you do not reject H0. And how do you know where is the rejection region? Critical value decide the rejection region. Okay. So that is question 11. Question 11, we get here. Oh, there are 2 more parts. Fantastic, this question. So far, in question 11, we did left tail test. This is an indicator, left tailed test. Okay, now, part B, asks you to test H0, sigma 1 square equal to sigma 2 square, and HA or H1, sigma 1 square not equal to sigma 2 square. And this is an example of two-tailed test. Two-tailed test. Okay, so what you do, you follow exactly what we did here. Okay, and you just change to here. Remember when we have here, I will just want to copy and paste and make one modification. So I am just going to copy this EXE, Control C. I actually copy all of them, then make modification, Control C. And then part B is a two-tailed test, okay, Control V. All right, so when you have, this is an example two-tailed test, you still enter sample 1 as list 1, sample 2 as list 2, and you still press F3 test, and then F4, F test, data is list, and this time, sigma 1 not equal to sigma 2 here. I have to change here. How do I change this one?
It would be not equal to.
Excellent, not equal. But I cannot type in not equal, so how do I do? This represents not equal, okay? So sigma 1 not equal to sigma 2 because H1 perspective, calculator is based on H1 perspective. Okay, you have to type in not equal. Okay, so after that, you press EXE, and this time I'll change my calculator. So, see, I changed sigma 1 not equal to, it's difficult to, sigma 1 not equal to sigma 2. Everything else unchanged. just change not equal, okay? And then press EXE. I get F value the same, 0.2538. However, P value, I get, the P value is not this one. P value I get 0.1650, 0.1650. If you notice, this P value is happen to be 2 times of the previous one. Okay, the previous one. So this is my P value. Again, you compare this P value, it is still greater than alpha. No, this P value, hold on, I have to double check. Sigma 1 not equal to sigma 2. Yes, correct. Correct. Okay, I'll check here. 0.0. And then you compare P value with alpha. Okay, this time P value greater than alpha. The other time I get P value 0. This is this 0. I'll double check my answer though. So before I have smaller than sign 0.0. 0.082, 0.082. This P value, where is my alpha? 0. No. This P value, okay, go back to one-tailed test, okay? This P value 0.08, nobody pointing out. I made a mistake here. This P value greater than alpha. Did you see it? Because alpha 0.01, this P value 0.08. Did you see it? When P value greater than alpha, you do not reject H0. Do not reject H0. So I have to change the answer here. The answer is do not reject H0. And then C and D, I have to select one. So C and D has, no. Hold on, not here, not B, here. Between C and D, I have to choose one because they both appear do not reject H0. Do not reject H0 means H0 is correct. C said sufficient evidence, the variance is less than. D said insufficient evidence. Insufficient evidence, sample 1 is less than sample 2. So D is correct. Okay, because we do not reject H0. Means H0 is correct, H1 is wrong. Okay, insufficient evidence to conclude. Okay, any questions? Okay, so pay attention, okay? So anybody can make mistake. See, big mistake, 0.08 greater than alpha, okay, not smaller. Okay. So this is the left tail test. Now go back to our two-tailed test. Part B, that's why I wonder where is part B? Here, two-tailed test. In two-tailed test, I have a p-value 0.165. This is greater than alpha. Again, when p-value greater than alpha, do not reject H0 is the conclusion. Do not reject H0. Okay. And then you have to make your choice, A, B, C, D. Which one has do not reject, B and C. Okay, do not reject H0 means B said there is sufficient evidence sample 1 is different from sample 2. C said there's insufficient evidence that sample 1 is different from sample 2. Which one? Which one, B or C? C is correct, okay? There's insufficient evidence. Any questions? All right, so this is question 11, and last question is question 8. Question 8. Question 8, okay, is this question. A particular magazine identified the top accounting firms in 11 geographic regions across a certain country, even though all 11 regions reported growth in the past year. Region A and Region B reported the highest combined growth with 15% and 19% respectively. A characteristic description of the accounting firms in these regions included the number of partners in the firm. The accompanying table contains data on the number of partners, complete A to D. Okay, so where is my data? The data is here. So you have two regions, region A, region B. In each region, you have a number of partners. Okay, so this is the data looks like. And then the question asks you, at 0.01 level of significance, is there evidence of difference in the variability in numbers of partners for region A accounting firms and region B accounting firms? So A, B, C, D, which one? So the question is there evidence of difference? If you see the keyword difference, usually H1 is not equal. So choose the one, which one H1 has not equal. That's usually the correct answer. So in this case, D. Okay. And then compute the F test statistic and compute the critical value. State the conclusion. Okay. So how do I compute F test statistic? So again, I already entered first. You enter region A as list 1, region B as list 2. Okay, maybe here. List 1, you type in 159. Your calculator, 43, etc., etc., etc. The last number for list 1 is 13. So those data is your list 1, and then you type in list 2. List 2, the first number is 60, then 135, 60, 135, okay, and then etc., etc. The last number for B region is 19, 14, 19, okay. So the last number is 19. 19. So type in list 1 and list 2 on your calculator. Okay. So this I will show you. This is my, and I typing in list 1 is my Okay, I already pre-type in, okay, to save some time. So once you type in those lists, and then you do press F3 test, okay, and then F4, F test, so F3, F4. And after that, data select list, data is a list, and then list 1 is your list 1, list 2 is your list 2, okay? And frequency 1 is 1, just accept default setting, that is 1. Frequency 2 is 1, and then you press EXE, okay? Sample F test, data list. After data list, you have to choose sigma 1, sigma 2, okay? Data list, you have to choose sigma 1, smaller or greater or equal. You have to do this. Select that selection. So let's see our question. See, we should select not equal. So sigma 1 not equal to sigma 2 on your calculator. Okay. So I missed a step here. Sigma 1 not equal sigma 2. Okay. Sigma 1 not equal to sigma 2. And then the rest are the correct. You press EXEK. So after that, you press EXE. You get test statistic F. I get 0.2538. And I also get the p-value. P-value equal to 0.1650. Okay, so that is we found F test statistic. Okay, and next question, what is the critical value? And for critical value, you follow this step. Okay, F5, F4, F3. You follow F5, F4, F3. This one critical value for F, but you are given the original data. Okay, critical value. Inverse F, data is list. Data is, you can choose data variable. Data critical value has nothing to do with the original data, okay? So after F5, F4, F3, data variable, and then area, where is my alpha? Because this is two-tail test, area, you use half alpha, okay? We need to find out where is alpha. Here, alpha 0.01, okay? So alpha 0.01 divided by 2, 0.005, that is area, okay? So 0.005 is the area. NDF, okay? NDF, degree of freedom for numerator, okay? So that is sample 1 size minus 1. If you count how many data here, sample 1, $13, okay? So 13 minus 1, it is 12. Okay, and then DDF, you have to count how many data in B. $15. So 15 minus 1 is 14. Okay, so NDF is 12 and then 14. And then you press EXEK. And you would get 4.428. That is the critical value. Okay. 4.428 critical value. And p-value, we already did p-value, use calculator. Okay. All right. That's all for today's meeting. And basically, I just took questions from students and I go over it. Are there any other questions? In summary, what we did today, we did a lot actually. We did F test. We learned how to use formula to find F test, okay, S1 square over S2 square. And we also learned how to use calculator to find F test, this question, and the p-value. And based on p-value, we make conclusion, okay? So this is, and we also did the independent sample test, the last question here, question 11. Okay. Beside calculator, by the way, you can also use the table, see, to find the critical value. And how do you use table? I'll just briefly introduce, because since it is here. First, you found the degree of freedom for denominator, it is here. All these values are degree of freedom for denominator. Then you found numerator degree of freedom, okay? And then you have to make sure the upper tail area is 0.01, okay? And then intersection part is the degree of freedom. So for example, in this question, the question we have just given, we have 13 data for A, 15 data for B. So degree of freedom numerator is 12, you locate 12. Degree of freedom for denominator, you locate 14. And suppose upper tail area 0.01, so the intersection part, it is this number. But in our case, our upper tail area 0.005, so you can use this table. You have to look, use this table here. Upper tail area 0.005, degree of freedom for numerator 12, degree of freedom for denominator 13, and then see, this is the critical value, exactly the same as we found from calculator, 4.43, 2 decimal place. Okay. All right, that's all for today. Any last minute questions? All right, thank you for your participation. Good night, and I look forward to see you next Saturday.
Thank you, Professor.
You're welcome.